Hey everyone, this is Miss Emily. So I'm looking at question number 7 on the correlations quiz, and I just wanted to go through and show you again how to answer all the questions using Desmos. So the first thing I'm going to do is go over here to this plus sign. It says add item, and click on table, and x1 and y1 pop up. And so in the x1 column, I want to type out all the x values. So for this question, it was 1980, 1990, 1997, 2000, 2005, and 2011. And then I want to come over to the y1 column and type in the y values. So the x values are years, and the y values is the number of people in the population. So this is 4,400, 5,100, 58, 52, 60, 80, 64, 50, and 7,000. Okay, and then you want to just double check that you typed in all your values correctly. It looks like I did, so just make sure you do that so that you're not answering all the questions slightly off. The next thing I want to do is come over here to this little magnifying glass with a plus sign in it. It's called the zoom fit button, and that way I can see all of the dots. So the first question is, what is the correlation coefficient? So at this point, I don't have a linear regression line, so I don't really know what my correlation coefficient is. So I have to come down here to this next row and type in y1, and then go to the keyboard, hit ABC, and then down here is the little squiggle looking symbol, and that's the approximation symbol, so I want to click on that, do m x1 plus b. Okay, so two things. I used y1 and x1 instead of just y and x, because that is what my table says. So Desmos automatically does x1 and y1 for you, instead of just plain x and plain y. So we need to use y1 and x1 to show that we're referring to that table specifically. Another thing is that we used this squiggly line, which is the approximation symbol, instead of the equal sign. So it's important that you do that as well, because the linear regression line is approximating the data. It's not going through every single point. Okay, cool. So now R pops up, and we know that R is the letter we use for correlation coefficient. So the answer to that question would be R equals 0.998. Now, the next question is whether this is positive, negative, or no correlation. You can either look at the graph and see that the dots on the scatter plot are increasing, or that the linear regression line is increasing, or you could also just look at the value of R. So there's not a negative sign in front of 0.998, so we know that it's a positive correlation. So that would be the answer to that second part. Then the third part is strong, weak, moderate, or none. So we talked about the strength of a correlation is measured using that correlation coefficient. And so if you look back at that table of values, I had y'all take notes on R values and which was strong, which was weak, which was moderate. And in this case, 0.998, that's actually very strong. So without even looking back at those notes, you should be able to recognize that anything that's 0.9 is going to be a strong correlation. So now it's asking for the linear regression equation. So we've already plotted the line, but we don't yet have the linear regression equation explicitly written out. But when you type this out, not only does it give you R, but it also gives you M and B. So here at the bottom it says M equals 84.9102 and B equals negative 163766. So we know that we're going to write our linear regression equation in the form y equals mx plus b. So if this helps you, just write out y equals mx plus b first, but we need to replace this m with the number that it gave us for m, and we need to replace b with the number that it gave us for b. So make sure that you're keeping the sign correct also. So we want to do minus b. And then it should put a red line over that black line. And this is what you need to write on your paper for linear regression equation. So now it says, what is the predicted population in 2005? So if we go up to the table, you'll notice that 2005 is a value, and that the population was 6,450 people. But this is the actual value, because each point that's plotted in a scatter plot is the actual value. And what we're being asked is the predicted value, or the predicted population in this case. So we want to use our regression equation that we've just written out, because we know that that gives us our predicted values rather than our actual values. So what would be useful is to convert this to a table. So go up to this settings looking button, it's called edit list, and then go down to where we wrote our regression equation and click the table looking button, it's called convert to table. So now, like we talked about in class, these x values automatically pop up, and it's not necessarily the values that we're looking for. So I didn't ask what was the population for year 0, I asked what was the predicted population in 2005. So you want to delete just any of these and then type in the value that you were actually looking for. And then this right here, 6,478.951 would be your answer, but we know that we can't have a percentage of one person, so you would round that up, and your predicted population should be 6,479 or 6,478. I'll take either of those, or I'll take it as a decimal because I didn't say that I wanted it as a whole number, even though it makes the most sense in context. So that's the predicted population for the year 2005. And now it's asking, what is the residual for the year 2005? So you could go about this two different ways. We know the actual value is 6,450, and now we know the predicted value. So the residual is the actual minus the predicted. So you could do it that way, or you could just come up here where it says E1 and click plot, and then all these numbers show up. So these numbers in the E1 column are the residual values for that year. So go down to 2005, and the residual value is negative 28.79, so on. So you should find that negative 28.79, so on, is your residual value for the year 2005. You should also find that if you use the by hand method and take the actual value minus the predicted value that we found down here. Okay, the next question is predict the population in 2015. So in this case, 2015 is not in our original table. And what we don't want to do is type 2015 into our original table, because those are our actual values. And we're interested in finding a predicted value, so we need to come here to our predicted table. And under X, put 2015. And now the y value that pops up is 7,328 and some change. So you want to say that your predicted population for 2015 is 7,328 people. Once again, you can leave the decimal and I'll give you credit for it, but in context, it makes the most sense to round down for the number of people. Or if it's like 0.999, you might as well round up, but it makes the most sense in context to round down. Okay, so that was all the questions for that table. I hope this clears it up and gives you some more practice with it.